This is SpaceTime, Series 28, Episode 143, for broadcast on the 5th of December 2025. Coming up on SpaceTime, lightning detected on Mars for the first time, NASA's new images of Interstellar Comet 3I Atlas, and scientists discover that moss can survive in the vacuum of space. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
NASA's Mars Perseverance Rover has captured evidence of electrical discharges, that is lightning, in the red planet's atmosphere. The findings, reported in the journal Nature, were recorded in two dust devil whirlwinds inside Jezero Crater. On Mars, winds occasionally stir up fine dust, and it was at the centre of two of these dust devils that the six-wheeled car-sized rover's Supercam microphone recorded some especially strong signals. Analysis showed there were electromagnetic and acoustic signatures of electric discharges comparable to the small static electricity shocks that can be experienced on Earth when touching a door handle in dry weather. Although long theorised, this is the first confirmation of the existence of electrical discharges in the Martian atmosphere. The phenomena can be explained by friction between tiny dust particles. They become charged with electrons, then release their charges in the form of electric arcs a few centimetres long, accompanied by a loud, audible shock wave. On Earth, it's well known that dust particles can become electrically charged, especially in desert regions, although this rarely results in actual discharges. But on Mars, the thin atmosphere, mostly made up of carbon dioxide, makes this phenomenon much more likely to occur. See, the amount of charge needed to form sparks is much lower than on Earth. The discovery of these electrical discharges profoundly changes science's understanding of Martian atmospheric chemistry. These phenomena show that the Martian atmosphere can reach significant levels of charge to speed up the formation of highly oxidizing compounds. And these substances can destroy organic molecules on the surface, as well as numerous atmospheric compounds, thereby profoundly upsetting the photochemical balance of the atmosphere. The discovery could help explain the surprisingly rapid disappearance of methane on Mars, which has now been a subject of scientific debate for several years. The electrical charges required for these discharges are likely to affect the transportation of dust on Mars, thus playing a central role in Martian climate, the dynamics of which are still largely unknown. Of course, they also pose a risk to electronic equipment on current missions to the red planet's surface, and they could also constitute a danger for future manned missions to Mars. The microphone on the Supercam instrument aboard Perseverance was first activated on Mars in 2021, the day after the rover landed on the red planet. Switched on every day, it's now collected over 30 hours of sounds from the red planet, the wind blowing, the noise of the blades of the Ingenuity helicopter, and now some 50 electrical discharges. This is SpaceTime. Still to come, NASA's new images of Interstellar Comet 3I Atlas, and a new study has shown that moss can survive the deadly vacuum of space for up to 15 years. All that and more still to come on SpaceTime. Hot on the heels of the European Space Agency's observations of the Interstellar Comet 3I Atlas, NASA has published its own observations. ESA's observations, using its ExoMars Trace Gas Orbiter, improved the comet's predicted location by a factor of 10, capturing the alien visitor as the comet passed relatively close to Mars, approaching to about 29 million kilometres of the red planet on October the 3rd. ExoMars got about 10 times closer to 3I Atlas than telescopes on Earth, and observed the comet from a new viewing angle. The triangulation of this data, combined with data from Earth, helped make the comet's predicted path much more accurate. It also helped put an end to all those wild claims that 3I Atlas may be an alien spacecraft. NASA's MAVEN, the Mars Atmospheric and Volatile Evolution Orbiter, also monitored the comet for 10 days as it slipped behind the Sun and out of view of the Earth. MAVEN observed 3I Atlas in ultraviolet light, exposing the glow of hydrogen silently pouring off the comet's icy surface. These data are helping astronomers uncover new clues about the comet's hidden chemistry. Hints about ancient water in other star systems, and even the ratio of hydrogen to deuterium could reveal where this vagabond traveller was born long before it was spotted in our solar system last July. As well as MAVEN, NASA also turned the Mars Reconnaissance orbiter towards 3i Atlas, capturing one of the closest images of the comet yet. Meanwhile, down on the Martian surface, the Perseverance Rover also grabbed a faint glimpse of the comet from its position on the rim of Jezero Crater. And it doesn't end there. NASA's Stereo spacecraft captured images of the comet between September the 11th and October the 2nd, and the joint NASA-ESA SOHO spacecraft observed the comet from October the 15th to the 26th. Images from NASA's Punch mission, which launched earlier this year, revealed the comet's tail during its observations between September the 20th and October the 3rd. NASA's Psyche and Lucy missions, currently on their respective outbound journeys to study various asteroid targets further out in the solar system, were also able to observe 3i Atlas. On September the 8th and 9th, Psyche acquired 4 observations of the comet over 8 hours from a distance of 53 million kilometres away, and these images will further help scientists refine the comet's trajectory. Then on September the 16th, Lucy took a series of images from 386 million kilometres distant. Stacking all these images together provides details on the comet's coma and tail. Back in August, both the Webb and Spherix telescopes also captured imagery. Comet 3i Atlas will fly closest to the Earth around December the 19th. That's when it will pass at a distance of 274 million kilometres, which is still almost twice the distance between the Earth and the Sun. Needless to say, astronomers will continue to observe the comet as it continues its journey through our solar system, passing the orbit of Jupiter in early 2026, travelling at some 250,000 kilometres an hour, before finally vanishing back into interstellar space, never to return. This is SpaceTime. Still to come, a new study has shown that moss can survive the deadly vacuum of space for up to 15 years. And the December solstice, the ticking time bomb of Eta Carina, and the rock comet Phaeton are among the highlights of the December night skies on Skywatch. A new study has shown that moss could survive in the deadly vacuum of space for up to 15 years. The findings, reported in the journal iScience, are based on moss spore samples sent to the International Space Station, where they survived exposure to the vacuum of space for up to 9 months before returning to Earth. The study's lead author, Tomomichi Fujita from Hokkaido University, says most living organisms, including humans, can't survive even briefly in the vacuum of space. However, the moss spores retain their vitality after 9 months of direct exposure. He says the findings provide striking evidence that the life that's evolved here on Earth possesses, at least at a cellular level, intrinsic mechanisms to endure the conditions of space. Tomomichi and colleagues subjected a well-studied moss, commonly known as spreading Earth moss, to both real and simulated space environment conditions, including high levels of ultraviolet radiation, extreme high and low temperatures, and vacuum conditions. They tested 3 different structures from the moss: proton matter, or juvenile moss, brood cells, or specialized stem cells that emerge under stress conditions, and sporophytes, or encapsulated spores, in order to find out which had the best chance of surviving in space. The authors found that ultraviolet radiation was the toughest environment to survive, and the sporocytes were by far the most resilient of the 3 moss parts. None of the juvenile moss survived high radiation levels or extreme temperatures. The brood cells had a high rate of survival, but the encased spores exhibited 1,000 times more tolerance to ultraviolet radiation. And the spores were also able to survive and germinate despite being exposed to 196 degrees Celsius for over a week, as well as after living in 55 degrees Celsius heat for a month. The samples had an 80% survival rate and were able to successfully germinate when they returned to Earth. The authors then analysed how well the moss survived in a computer model, which predicted that the spores could have survived for up to 5,600 days. That's around 15 years. The authors say the results demonstrate the remarkable resilience of moss spores and reveal the potential of terrestrial plants to endure extreme environments. This is SpaceTime. Time now to turn our eyes to the skies with December Skywatch. December is the 12th and final month of the year in both the Julian and Gregorian calendars. December got its name from the Latin word decem, meaning 10. That's because it was originally the 10th month of the year in the old Roman calendar, which began in March. Of course, the astronomical highlight of the month is the December solstice, which this year occurs at 2:02 in the morning of Monday, December the 22nd, Australian Eastern Daylight Time. That's 10:02 in the morning of Sunday, December the 21st, US Eastern Standard Time, and 15:02 in the afternoon, Greenwich Mean Time. This is when the Sun appears to reach zenith directly over the Tropic of Capricorn. In the United States, in the Northern Hemisphere, it marks the winter solstice, signifying the first day of winter. But the good news is that from now on, the days start to get longer again. On the other hand, south of the equator, summer has well and truly arrived, and the days are usually at their warmest. Earth's seasons occur because of the tilt of the planet's spin axis, which is inclined at 23.4 degrees in relation to the Sun. Now, generally speaking, Earth's axis always points to the same position in space, regardless of the position of the Earth as it orbits around the Sun. So on the day of the December solstice, the Earth's south pole is tilted towards the Sun, so its southern hemisphere gets more daylight and more direct sunlight, so it's hotter and its southern hemisphere is in summer. 6 months later, during the June solstice, the North Pole is tilted towards the Sun, and so it's the northern hemisphere which experiences summer, while the southern hemisphere gets less daylight, longer nights, and the sunlight strikes the surface of the planet at a shallower angle, meaning less heat, and so the southern hemisphere is in winter. In between these two, we have the March and September equinox. That's when the northern and southern hemispheres get roughly equal amounts of daylight and heat, giving us the seasons of spring and autumn. Now earlier we said that generally speaking, Earth's axis always points to the same position in space, regardless of Earth's orbital position around the Sun. And while that's true in our day-to-day lives, over geologic time, approximately 25,772 years, a gravity-induced effect known as axial precession causes a slow and continuous change in the orientation of Earth's rotational axis. You can see the same effect in the precession of a spinning top as its axis traces out a pair of cones joined by their aspices. Earth's precession was historically called the precession of the equinoxes because the equinoxes moved westwards along the ecliptic relative to the fixed background stars. This slow precession of the Earth's axis means that over 25,772 years, the positions of the south and north celestial poles appears to move in circles against the space-fixed background stars. So, while today the star Polaris lies approximately at the North Celestial Pole, this will change over time, and Gamma Cephei will ultimately become the North Star in about 3,200 years from now. It also means the seasons would slowly move through different calendar months, but we make adjustments to the calendar to compensate for that. In most parts of the world, the seasons begin on the day of the solstice or equinox. These are known as astronomical seasons and are based on Earth's orbital position and tilt as it travels around the Sun. However, in Australia, seasons begin on the first day of a specific calendar month, that is March for autumn, June for winter, September for spring, and December for summer. These are known as meteorological seasons and are based on the annual temperature cycle and divided into 4 consistent 3-month periods in order to simplify weather tracking and climate trends. They align more closely with the seasons as they are typically experienced in terms of weather. Because of the relatively small amount of elongation in Earth's orbit around the Sun, Earth's seasons are determined by its axial tilt rather than orbital distance. Currently, Earth's closest orbital position to the Sun, known as perihelion, occurs about 2 weeks after the December solstice, and its furthest from the Sun, known as aphelion, about 2 weeks after the June solstice. That means the next perihelion will occur at 4:15 in the morning of Sunday, January the 4th, 2026, Australian Eastern Daylight Time. That's when the Earth will be just 147,099,894 kilometres from the Sun. That's 12:15 in the afternoon of Saturday, January the 3rd, US Eastern Standard Time, and 5:15 in the afternoon, Greenwich Mean Time. Like axial precession, Earth's orbit also changes gradually over geologic time, getting more or less elongated and changing perihelion and aphelion. Even the degree of the tilt of Earth's axis changes over thousands of years. Now, collectively, all these changes are known as Milankovitch cycles, after the Serbian geophysicist and astronomer Milutin Milankovic, who in the 1920s hypothesized that variations in eccentricity, axial tilt and precession resulted in cyclic variations in solar radiation reaching the Earth, and that this orbital forcing strongly influenced Earth's climatic patterns. Okay, let's start our tour of the December night skies in the west, where midway up from the horizon is Fomalhaut, the brightest star in the constellation Pisces Austrinus, the southern fish. Fomalhaut is a very young white spectral type A main sequence star, about 1.8 times the diameter of the Sun, and located reasonably nearby, just 25 light-years away. A light-year is about 10 trillion kilometres, the distance a photon can travel in an Earth year at 300,000 kilometres per second, the speed of light in a vacuum and the ultimate speed limit of the universe. Now, main sequence stars are those undergoing hydrogen fusion into helium in their cores. Astronomers describe stars in terms of spectral types, a classification system based on temperature and characteristics. The hottest, most massive and most luminous stars are known as spectral type O blue stars. They're followed by spectral type B blue-white stars, then spectral type A white stars, spectral type F whitish-yellow stars, spectral type G yellow stars, that's where our Sun fits in by the way. Then comes spectral type K orange stars, and the coolest and least massive known stars are spectral type M red stars. Now, each spectral classification can also be subdivided using a numeric digit which represents temperature, with 0 being the hottest and 9 the coolest, and a Roman numeral to represent luminosity. So, our Sun is a G2V or G25 yellow dwarf star. Also included in the stellar classification system are spectral types L, T and Y, which are assigned to failed stars known as brown dwarfs, some of which were actually born as spectral type M red dwarf stars, but they became brown dwarfs after losing some of their mass. Brown dwarfs fit into a unique category between the largest planets, which are about 13 times the mass of Jupiter, and the smallest spectral type M red dwarf stars, which are about 75 to 80 times the mass of Jupiter, or roughly 0.08 solar masses. In 2008, astronomers detected planets orbiting around Fomalhaut. At this stage, it's not known if anyone was looking back. 5,000 years ago, the ancient Mesopotamians used Fomalhaut to mark the northern hemisphere's winter solstice. Now, turning to the left of Fomalhaut is Achernar, or Alpha Eridani, the brightest star in the constellation Eridanus, the river. Located 139 light-years away, Achernar has 7 times the diameter of the Sun and rotates some 15 times faster, giving it a very obvious oblate shape. The effect of this rapid rotation is that the star flattens at its poles, but bulges in the middle. In fact, its equatorial diameter is about 50% greater than its polar diameter. It turns out Achernar is actually part of a multiple star system, Alpha Eridani A and Alpha Eridani B. The primary star, Alpha Eridani A, is a hot blue spectral type B main sequence star. Its smaller companion, Alpha Eridani B, is a spectral type A white star. Their pair orbit each other around a common centre of gravity at a distance of about 12 astronomical units. An astronomical unit is the average distance between the Earth and the Sun, about 150 million kilometres or 8.3 light minutes. Moving further left from Achernar and just above the horizon is Canopus, the brightest star in the southern constellation of Carina the Keel, and it's also the second brightest star in the night sky after Sirius. Canopus is a white giant star nearing the end of its life. It's located about 310 light-years away. It has about 8.5 times the mass of the Sun, but it's expanded out to about 71 times the Sun's diameter. Canopus has some 1,300 times the brightness of the Sun, and in fact, it's the brightest star within 700 light-years of Earth. Its name originates in mythology from the time of the Trojan Wars and the navigator for Menelaus, the king of Sparta. Located between Canopus and the Southern Cross in Carina in the Trumpler 16 open star cluster is the ticking time bomb that is Eta Carina, a pair of huge blue stars undergoing the final violent phase of their existence for exploding as massive core collapse supernovae. The binary system is located some 7,500 light-years away and is buried in the Great Nebula of Carina, a massive cloud of gas and dust stretching some 6.5 to 10,000 light-years wide. The stars in Eta Carina are classified as highly luminous spectral type O blue hypergiants. The primary star is estimated to be around 150 to 200 times the mass of our Sun, with some 5 million times the Sun's luminosity, 800 times its radius, and a surface temperature of up to 32,500 Kelvin. The primary star in this binary pair is also the only known star to produce ultraviolet laser emissions. The companion star, although smaller than the primary at just 80 solar masses and 20 times the Sun's radius, is even hotter, with surface temperatures of around 37,200 Kelvin. The two stars orbit each other every 5.54 Earth years, cocooned in a gigantic twin-lobed cloud of gas and dust known as the Homunculus Nebula, a bipolar emission and reflection nebula. The primary star in this binary pair has lost about 30 solar masses in recent times. Both Eta Carina and its surrounding shroud of dust generate huge amounts of infrared radiation, making it the brightest infrared source in the sky. Eta Carina experiences tremendous outbursts. During one event, it became almost as bright as the star Sirius. Known as the Great Eruption, it began in 1837 and reached its peak in 1843, when it was one of the brightest objects in the night sky, before gradually fading away again by 1856. Eta Carina underwent another slightly smaller eruption in 1892 and has again been steadily brightening since about 1940. Both these stars are now nearing the end of their lives on the main sequence, and they're expected to go supernova in an astronomically short space of time. When they do go supernova, Eta Carina will be visible in the daylight skies even here on Earth. In fact, they could become brighter than the full moon for months on end. No one knows exactly when Eta Carina will go supernova. A single star, a star originally around 150 times as massive as the Sun, would typically reach core collapse as a Wolf-Rayet within about 3 million years. At low metallicity, many massive stars will collapse directly to form stellar mass black holes with no visible explosion, or possibly a subluminous supernova, and a small fraction will produce a pair instability supernova. But at solar metallicity and above, there's expected to be sufficient mass loss before collapse to allow a visible supernova to appear. Now, if there's still a large amount of expelled material close to the star, the shock wave formed by the supernova explosion impacting on the circumstellar material could effectively convert the kinetic energy into radiation, resulting in a superluminous supernova or hypernova, several times more luminous than a typical core collapse supernova and much longer lasting. Highly massive progenitors may also eject sufficient nickel to cause a superluminous supernova simply from the radioactive decay. Now, the resulting remnant would then form a black hole, since it's highly unlikely that such a massive star could ever lose enough mass from its core not to exceed the limit for a neutron star, about 2.3 or 2.4 solar masses. But the existence of a massive companion star brings many other possibilities into play. If Eta Carina A was rapidly stripped of its outer layers, it might become a less massive WC or WO type star when core collapse is finally reached. This would result in a Type 1b or Type 1c supernova due to the lack of hydrogen and possibly helium. And these supernovae are thought to be possible progenitors for some types of gamma-ray bursts. Now, a typical core collapse supernova at the distance of Eta Carina would look as bright as the planet Venus, the third brightest object in the sky after the Sun and Moon. On the other hand, a superluminous supernova could be 5 magnitudes brighter, possibly the brightest supernova in recorded history. But I'm pleased to say that, based on our current data, Eta Carina is not expected to produce a gamma-ray burst, and its axis isn't currently aimed anywhere near the Earth. And at 7,500 light-years away, the star is unlikely to directly affect terrestrial life forms on Earth thanks to our planet's atmosphere and magnetosphere. But the ozone layer of the planet could be damaged, as would orbiting spacecraft and any astronauts in space at the time. At least one paper has projected that a complete loss of the Earth's ozone layer is a plausible consequence, and that would result in a significant increase in ultraviolet radiation reaching the planet's surface from the Sun. But that would require a typical supernova to be closer than 50 light-years from Earth, and even a potential hypernova would still need to be closer than where Eta Carina is now. Another analysis of the possible impact of a supernova in Eta Carina discusses more subtle effects from the unusual illumination, such as possible melatonin suppression, resulting in insomnia and an increased risk of cancer and depression. Okay, on that note, let's turn to the east, and looking just above the horizon is the star that outshines Canopus to take the title of the brightest star in the night sky, namely Sirius the Dog Star. And next to it, in the east-northeastern skies just above the horizon, is the constellation of Orion the Hunter. There you'll see a very bright red star. It's a red supergiant called Betelgeuse, better known to most people these days as Betelgeuse. Don't say it 3 times. In ancient times, before centuries of mispronunciation, its name actually started out as Ibdal Yauza. Betelgeuse is one of the largest and most luminous stars visible with the unaided eye. Located some 430 light-years away, this bloated old red giant is reaching the end of its life. It's truly massive, some 1,100 times the diameter and 100,000 times the brightness of our Sun. Like Eta Carina, Betelgeuse is destined to explode as a core-collapse supernova sometime in the near future. Betelgeuse marks the right shoulder of Orion the Hunter, although it's all upside down from our perspective here in the southern hemisphere. That's because Orion was a hunter in Greek mythology, so the constellation was viewed from the northern hemisphere. The earliest known depiction of the Orion constellation was on a prehistoric mammoth ivory carving found in a cave in the Arch Valley in West Germany. That was in 1979. Archaeologists estimate that it had been fashioned between 32,000 and 38,000 years ago. The distinctive pattern of Orion has been recognised in numerous cultures around the world, including the ancient Babylonian star catalogues dating back to the Late Bronze Age. In Greek mythology, Orion was a gigantic supernaturally strong hunter of ancient times. He was the son of a Gorgon and Poseidon, also known as Neptune, the god of the sea in the Greco-Roman tradition. But the goddess Gaia became angry at Orion after he boasted that he would kill every animal on Earth. So she sent a scorpion to sting Orion to death. However, Ophiuchus the serpent-bearer revived Orion with an antidote. And this is given to be the reason why the constellation Scorpius chases Orion across the sky, with the constellation Ophiuchus standing midway between them. The other major stars in Orion include Rigel, Orion's left foot, a blue supergiant. Having exhausted its core hydrogen, Rigel has swollen out to between 79 and 115 times the Sun's radius. It's currently fusing heavier and heavier elements at its core, meaning it too will soon likely go supernova and collapse to form a neutron star. Rigel's estimated to be somewhere between 120,000 and 279,000 times the luminosity of the Sun. It's a binary system, located 860 light-years away. And it has a companion star, Rigel B, some 500 times fainter than the supergiant Rigel A and visible only through a telescope. Rigel B itself is a spectroscopic binary system comprising 2 main-sequence blue-white stars. Spectroscopic binaries are double star systems orbiting each other in such a way they can only be visually separated from our vantage point here on Earth by their different spectroscopic signatures. The 2 stars making up Rigel B are estimated to have 3.9 and 2.9 times the mass of the Sun respectively. And one of these stars, Rigel BB, may itself also be a binary system. Rigel B also appears to have a very close visual companion, Rigel C, almost identical in appearance. The third brightest star in Orion is Bellatrix, Orion's left shoulder. It's a spectral type B main sequence blue star with about 8.6 times the mass and 6 times the radius of the Sun. Bellatrix is about 250 light-years away. It has an estimated age of about 25 million years. That's old enough for a star of this mass to start consuming hydrogen in its core and begin to evolve away from the main sequence and turn into a blue giant. Now, if you look at the 3 stars which make up Orion's belt, you'll see another 3 stars which make up Orion's sword hanging from the belt, and again, that's hanging upwards for those of the southern hemisphere. And if you look carefully at the middle star, you'll notice it's a bit fuzzy looking. That's because it's not a star, but the Great Nebula of Orion, Messier 42. Located just 1,344 light-years away, Messier 42 is the nearest massive star-forming region to Earth. Its nebula is estimated to be some 24 light-years across, and it has the mass of more than 2,000 suns. The Orion Nebula is one of the most scrutinized and photographed objects in the night sky, and it's among the most intensely studied celestial features. The nebula has revealed much about the process of how stars and planetary systems are formed from collapsing molecular gas and dust clouds. By studying M42, astronomers have directly observed protoplanetary disks, brown dwarfs, intense and turbulent motions of gas, and the photoionizing effects of massive nearby stars in the nebula. The Orion Nebula contains a very young open cluster known as the trapezium due to the asterism of its 4 primary stars. Now, the trapezium itself is a component of the much larger Orion Nebula cluster, an association of about 2,800 stars, all within a diameter of just 20 light-years. One of the most stunning nebula in the constellation Orion is the spectacular Horsehead Nebula, Barnard 33. The Horsehead is a dark nebula located just to the south of the star Alnitak, which is the furthest east on Orion's belt, and is part of the much larger Orion Molecular Cloud Complex. Located around 1,500 light-years away, the Horsehead Nebula was first recorded in 1888. It's one of the most identifiable nebulas in astronomy. That's because of the shape of its swirling clouds of dark dust and gases, which bear an amazing resemblance to a horse's head when viewed from Earth. One of the astronomical highlights of the December night skies is the annual Geminids meteor shower, which usually peaks around December the 13th and 14th. Radiating out from the direction of the constellation Gemini, the Geminids are unusual in that they're not generated by a comet as most other meteor showers are, but are produced by the debris trail left behind by the asteroid 3200 Phaeton. That makes the Geminids, together with the Quadrantids, the only major meteor showers not originating from a comet. 3200 Phaeton is highly unusual. Its high orbital eccentricity more closely resembles that of a comet than an asteroid. And in fact it's speculated that it may be an asteroid that's simply run out of all the volatile gases that normally characterize a comet. Phaeton's orbit crosses all the inner terrestrial planets, Mercury, Venus, Earth and Mars. And because it does come relatively close to the Earth, this 5-kilometre wide space rock is classified as potentially hazardous. Phaeton will make its closest approach to Earth on December the 14th, 2093. But at that time it will still pass a relatively comfortable 2,960,000 kilometres away from our planet. Interestingly, Phaeton's named after the son of the Greek sun god Helios. Legend has it that Phaeton almost destroyed the Earth by stealing Helios' chariot and scorching the Earth with the sun, almost causing the apocalypse. Phaeton approaches the Sun closer than any other named asteroid, with a perihelion of less than 21 million kilometres. That's less than half of Mercury's perihelion distance. Coming so close to the Sun causes the asteroid's surface to reach over 750 degrees Celsius. Observations by NASA's Stereo spacecraft saw dust trails radiating off its surface. And in 2010, Phaeton was detected actually ejecting dust into space. Astronomers think the intense heat generated by its close approaches to the Sun causes fractures in the gravel and rocks on the asteroid's surface, similar to mud cracks in a dry lake bed. And Phaeton's composition also fits the notion of a cometary origin. It's classified as a Type B asteroid because it's composed of primarily dark material. Type B asteroids are thought to be primitive, volatile-rich elements of the early solar system. Its composition, orbit and dust trail have led astronomers to refer to Phaeton as a rock comet. The Geminids meteors have a yellowish hue, and they tend to be a bit larger and more solid than typical meteors from comets. Think of grains and rocks rather than dust particles. They also move more slowly, travelling at about 35 km per second compared to some cometary meteor showers which travel at speeds of up to 72 km a second. Interestingly, the Geminids are also thought to be intensifying every year, with recent showers seeing up to 160 meteors per hour under optimal conditions. In the Northern Hemisphere, expect to see up to 120 meteors per hour between midnight and 4 a.m, but only from a dark sky. Well north of the equator, the radiant rises about sunset, reaching a usable elevation from local evening hours onwards. In the Southern Hemisphere, the Geminids aren't nearly as spectacular. You won't see as many, perhaps just 10 to 20 an hour. That's because the radiant doesn't rise above the horizon at all. Now, for listeners in the Northern Hemisphere, there's a second meteor shower in December, the Perseids, which radiate out from the direction of Ursa Minor, the Little Dipper. The Perseids are generated by debris left behind by the comet 8P Tuttle. They're a compact stream, peaking during the night of December the 22nd and the early morning hours of December the 23rd. If you look towards the bowl of the Little Dipper, you might see about 10 meteors an hour. And now, with the rest of the December night skies, we're joined by senior science writer Jonathan Nally.
G'day, Stuart. Well, this time I thought we'd start off with the moon, actually, and the effect that it has on stargazing. Because to people who aren't astronomers, either amateur or professional, the moon is lovely. You know, it's up there, it looks very pretty, it looks lovely, and it helps us see in the dark at night time. The moon's great, isn't it? Well, not if you're an astronomer, or most astronomers at least. Some amateur astronomers, they love the moon. They look through the telescope at the moon, they take pictures of the moon, they study the moon. Some professional astronomers do the same, but I think it's fair to say that The majority of astronomers don't, and the majority of astronomers really don't like the moon. And I'll explain why, because the moon is just a nuisance to most astronomers, because the moonlight gets scattered in our atmosphere, and it makes the night sky appear to be a dark grey instead of black. You probably noticed yourself, if you go out on a night where there's a full moon, you don't see as many stars. But when there's no moon up, the sky's much darker and you can see quite a few more stars. That's because of this moonlight is being scattered in our atmosphere, and that makes the sky glow a little bit in a sense. And so that means it becomes impossible to see the faintest stars, and it makes it very hard to see what astronomers call deep sky objects, such as galaxies and things, which you need a telescope to see. But with the sky sort of faintly glowing a little bit, that ruins the contrast. Normally you'd have stars and galaxies and things on a pitch black background, but when the sky's glowing a little bit, it's not pitch black anymore. And if looking at something that is really faint and grey to start with, which is a galaxy, then that really makes it a lot harder. So that's why the best stargazing is done when the moon is below the horizon. So very often, say an amateur astronomer will delay their viewing for a few hours at night time till the moon's gone down, because you get a much, much nicer view. And you will get a good idea of this if you look at a star map, any star map, and you think, oh, look at what stars I can see out there in the night sky. Then you go outside and it's a full moon and you can't see hardly any of them. And if you happen to live in a big city as well and you've got the additional problem of light pollution nearby, then you might not even be able to see some of the brightest stars. You might only be able to pick out 6 or 7 bright stars. So anyway, the moon's not a favourite of many astronomers. And the reason I mention it is that this month we start off with the moon. It's a little bit more than half full and it's nice and high in the sky as December begins. So you don't see quite as many stars and things as you do at other times of the night on other days. And just because the moon's around the beginning of December, give it a few days and it will have disappeared, because the moon moves each night, because it goes around the Earth about once every 4 weeks roughly. So what is it, 15 degrees or something, moves each night. So give it a few nights and it will have moved out of the way and be below the horizon. So at the beginning of this month, we've got the moon up a little bit, so I think a few things are drowned out in its glare. And that's the price we have paid for having a nice, big, close, natural satellite. But anyway, what can we see? Well, for a start, this time of the year, we can see the 2 brightest stars. We definitely can see those. That's Sirius and Canopus. Sirius is quite low down in the east as darkness falls, and Canopus also is low down, but it's more to the southeast. Much higher in the southeast, we've got a bright star called Achernar. Now, this is the star that marks the southernmost point of a constellation most people have never heard of. It's called Eridanus, which means the river. It's a big, long, winding, thin constellation. Starts up near the celestial equator and wanders way down towards the sort of far southern sky. Achernar is an interesting star. It's got a bluish colour, and scientists have found that it is spinning so fast that it's actually flattened itself into an elliptical shape. It's much wider at its equator than it is if you measure it from pole to pole. And it is, in fact, the least rounded star, least spherical star that we know of so far in the entire Milky Way galaxy, because it's spinning. Because stars, you could think of a star as being, it's made of plasma or gas, but you can think of it being a spinning ball of liquid, and it just sort of spins out at the equator and flattens down at the poles. So yes, Achernar is really interesting. It's the least rounded star we know of. Now, above the eastern horizon, sort of more to the north, we find Sirius and go a little bit to the north, so going to the left, there's the constellation Orion, which has risen up over the horizon, bringing with it its 2 brightest stars. You've got Rigel and Betelgeuse, 2 very famous stars. And you can always easily pick the constellation Orion, even when it's down low and there's other things in the way, because it has 3 stars in a straight line, right through the middle of it. They are the stars in the belt of the clothes that Orion the Hunter is wearing. Because Orion is the constellation of the Hunter, and right through the middle is his belt. Now, if you're looking for the Southern Cross, at the moment it's upside down and it's way down on the southern horizon. In fact, depending on the latitude of where you're viewing from, it might even be below the horizon. It will be for quite a few people, in fact. So you might not be able to see it at all. Yeah, and if that's the case for you, you're going to have to wait until the early morning hours after midnight. Then, as the Earth has rotated a bit, the Southern Cross will have risen higher in the sky. If you're not keen on waiting up after midnight, you're going to have to wait a few months, in fact. The best time to see the Southern Cross is middle of the year, March through to August, when it's up nice and high during the evening after the sun has set. Now, low down on the northeastern part of the sky are 2 star clusters that we speak about quite often on the show. And these ones are really worth seeking out. One's quite large and one is quite small. The large one is called the Hyades, and it's part of the constellation Taurus. The Hyades looks like a sort of a wedge or triangle-shaped group of stars, quite spread out, but in a definite triangle sort of shape. And there's an unrelated but much brighter red star called Aldebaran in one corner of this triangle. Aldebaran is the brightest star in the constellation of Taurus. The other cluster is a bit more to the north, and it's smaller, and it's called the Pleiades, or the Seven Sisters. We've spoken about this one many times on the show. And despite the name Seven Sisters, most people can actually only make out about 6. And again, it depends on light pollution and whether the moon's up and all that sort of thing, and how good your eyes are, with your glasses like I do, that sort of thing. And yeah, even though you can see about 6 of the stars, the cluster actually has about 1,000 members in it. It's quite a big star cluster, but most of them are very faint. With a pair of binoculars, you'll see more. With a telescope, you'll see more again. But even so, like long exposure photographs will reveal that there are about 1,000 stars in this cluster. But don't worry about that. Just get a pair of binoculars or a small telescope onto this cluster, and you'll thank yourself for doing so, because it is really, really pretty. It's just the most glorious little cluster of bright, sparkly stars. And if there's a bit of upper atmospheric wind, which is what makes the stars twinkle, we've got just a little bit of twinkle with the Pleiades. It just looks like a little bunch of jewels hanging in the sky. It's really lovely.
They've just done some new studies of the Pleiades, and they've discovered that it's actually part of a much larger open star cluster, about 3 times as big. There are 2 other sections to it, and they now call it the Pleiades Complex because it's so huge. Still haven't worked out exactly how far away it is from us. There's always been some discrepancy there, and that's still there. But they now know by looking at other stars in the area that they're all part of the same open star cluster, which they didn't know until just this month.
There you go. So we're learning new things all the time, and this is why you need, you can't just rely on the naked eye. That's why astronomers have big telescopes. And what you say about, not knowing the distance to things, it really is remarkable how, even in this day and age, there are other stars and clusters and galaxies, whatever, we don't really know the distance to. It's funny that we can know pretty accurately, at least in terms of redshift, how far away millions and millions of galaxies are. But even things just fairly nearby within our own galaxy can be quite hard to pin down the distance. There are various different techniques that astronomers can use to measure distances, and some are really good at getting accurate distances if something's quite close, and there are pretty good techniques like redshift for measuring how far away something is if it's a long, long way away. But sometimes in the middle area, it's a bit harder to pin down exactly how far things are. So in terms of the planets, and what can we see? Well, the only planet that's up at the moment in the early evening is Saturn, but that's okay. Saturn's really good to look at, with its rings and everything. It's fairly bright, Saturn, at the moment, and has a yellowish tinge, which does make it stand out. Next planet up is Jupiter. It's not above the horizon as evening falls. You've got to wait until about 11 p.m. at the beginning of December for it to rise over the northeastern horizon. But each night it'll be rising a little bit earlier, so by the end of the month it'll be only 9 p.m. when it's coming up over the horizon. So that makes it a bit easier for people to get out and have a look. Now, and how to find it? Well, if you look for that constellation Orion I mentioned earlier, and you've got one of its stars called Betelgeuse, if you just look between Betelgeuse and the horizon, just sort of straight down, Jupiter is right there between Betelgeuse and the horizon, which can't miss Jupiter. It's really big and bright. Mercury, little planet Mercury, the innermost planet, it's visible only in the half hour or so before sunrise this month, but it will be extremely hard to spot because it's going to be right in the middle of the sort of dawn glow before the sun has risen, but as the sky's getting light. So Mercury is a tiny little dot of light to begin with. So with a bright sky behind, a bright orange sky with the sunrise, you probably won't be able to spot it. And unfortunately, the other 2 main planets that we normally look at, Venus and Mars, they're also lost in the glare of the morning and the evening twilight, respectively, all month. So we're going to have to wait a good 2 or 3 months before they come back on the scene again. And that, Stuart, is the sky for December.
That's senior science writer Jonathan Nally. And this is Space Time. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details.
You've been listening to Space Time with Stuart Gary. This has been another quality podcast production from Bytes.com.